Sure? That is, if you have to write this carefully, variance of xt is variance of phi xt minus 1 plus v. What is variance of x plus y? Variance of x plus variance of y plus 2 covariance xy. Right? So if this you think of this as x, if you think of this as y, this is going to be variance of phi xt minus 1, which is phi square variance of xt minus 1. Okay. Which is phi square plus variance of x. So this is variance of x, this is variance of y, variance of vt, which will be sigma square v plus 2 covariance xt minus 1 v. Right? Now what do you think of the covariance xt minus 1 and vt? What is xt minus 1? What is vt? What do you think will that covariance be? So yt, suppose think of xt as being equal to some constant into the value of xt in the last period plus a random shock this period. Xt is the value of x today is xt, which is the value of x in the last period multiplied by a constant plus a random shock in this period. Vt is the random shock in this period. Xt minus the value of x in the last period. Right? So value of x in the last period. So is there any, should there be a relationship between Vt and xt minus 1? No. Because xt minus 1 is the value of x in the last period, Vt is a random shock in this period. And therefore they will be independent. It's sensible to assume that they are independent. And if they are independent, this term will be 0. Right? Now we have assumed xt to be a random variable. What is xt? The value of a random variable in time period t. What is xt minus 1? The realized value of the random variable in the last period with the same random variable. That's why we assumed it has the same mean, and with the same random variable will have the same variance. Right? Sure, because xt is a random variable, x is a random variable, xt is the value of that random variable in this period coming from a probability distribution. Xt minus 1 is the value of a random, the same random variable coming from a probability distribution in the last time period. We have assumed it's the same random variable, so we have the same mean and the same variance. Right? So we will call this, so this will be sigma square x is phi square sigma square x plus sigma square v. Yeah? Everybody gets this? No? The variance of xt and the variance of xt minus 1 will be the same. Because xt is the value, so we think of GDP. Value of GDP today is some random number into the value of GDP in the last period plus a random shock in this period. There is no structural change in the economy. Last year GDP and this year GDP follow the same probability distribution. So the mean of the probability distribution today and the mean of the probability distribution for GDP yesterday is the same. Their variance is also the same.